Welcome. In this video, I'm going to cover a very uh, commonly used and well-known rule for differentiation, or taking the derivative of the function, and that is known as chain rule. I'm a little too zoomed in here. Okay. And it's known as chain rule. So what chain rule covers is taking the derivative of a composite of functions, right? So basically the derivative of f of g of x. And my old calc teacher actually he used a fun little rat that he wrote to teach chain rule. And the way that went, it went you take the derivative of the outside and leave the inside alone. Take the derivative of the inside, multiply and go. So actually what we ended up seeing is that the derivative of the composite of functions is f prime of g of x, so that like kind of internal function being left alone, the outer function being taken the derivative of, and we multiply, so this is the multiplication symbol right here, by the derivative of the internal function. So now, I think the most important thing is kind of trying to find when you see a composite of functions. So that can be really many different cases where you can put some kind of general function inside of another function, right? Or you can kind of see a function inside a function. So let's say you had sine of 2x. In this case, sine is the outer function, f of x, and 2x is the inner function, g of x. So if we take the derivative of this, let's give some definition here. So f of x equals sine of x, right? And we said g of x equals 2x. So then let's find the derivative of both of those functions. So according to sine rule, we know that f prime of x equals cosine x. And g prime of x, according to power rule, that kind of like coefficient idea of, slope and whatnot, it would equal 2, right? It would be a constant slope. So according to our fun little friend here, chain rule, the derivative of sine 2x would equal the outer function, the derivative of the outer function, with the inner function left intact inside it. So you see this is f prime of g of x. So g of x is still left as it was inside of f prime, but then we multiply by the derivative of g of x, right? So what we're basically left with is 2 cosine of 2x. And like a little quick shortcut when you have the inner function as just a linear function like that, it'll always be the derivative of the outer function with the inner function left intact times that coefficient. It's just that coefficient, and it's that quick. Here, let's do one more example, just with very common chain rule. So let's say we had d dx. So we're taking the derivative of some function of e to the power of cosine of x. and we move on. What is that? So first, let's define our functions here. So let's say that f of x is equal to e to the x, right? And let's say that g of x would equal cosine of x, because f of x is kind of this outer function, and g of x is a function that's plugged into that function. So you see how cosine is kind of plugged into x here. So cosine is the exponent of e to the x. So we take the derivative of both of those functions. So this would be e to the x and g prime of x would actually equal negative sine x, right? So remember, when we have a composite function like this, you take the derivative, we use chain rule, and that is the derivative of the outside, leave the inside alone, take the derivative of the inside, multiply and go. So we take f prime of x, which is e to the x, right? And we keep that inner function left intact. So what we see is with e to the x, we're left with that original function, but we still need to multiply by the derivative of the inner function, and that's negative sine x. So this ends up equaling negative sine x times e power of cosine x. And there is actually one more example I want to show you, and that is something that involves chain rule with a combination of other rules. So chain rule can be used is often actually used with both product rule and quotient rule. But I'll show you the example for product rule here. So let's say we want to take the derivative of let's say we had ln of sine x times x to the fourth. So if you remember chain rule would be f. So let's say this like this composite functions is just like an f of x, and this is g of x. Chain rule would be f prime of x times g of x plus g prime of x times f of x. So if you want to find, so let's say f of x would equal ln of sine of x. If we wanted to find f prime of x, we would take the derivative of the inside, right? Ln x is basically that outside function, right? Take the derivative. I'm sorry. Take the derivative of the outside. Take the derivative of the outside, which is ln of x. The derivative of that is 1 over x. But you leave the inside alone, so you keep that inside function substituted into x. So instead of writing 1 over x, we substitute sine of x for x. So you get 1 over sine x. Right? And then we multiply by the derivative of the inner function. So that's actually cosine x. So following product rule now. So now we have found f prime of x, and that used chain rule. So now following product rule. So f prime of x, which was this, times x to the fourth, plus, then we'd have, well, I'm just doing g prime of x real quick. So g prime of x times f of x, which is ln of sine of x. And that would be the derivative of this function. So that's how chain rule kind of works together with other rules of differentiation. And with those three rules, you can find the derivative of basically any function. So keep practicing, keep learning, keep wondering. Thanks for watching this video.